Hello everyone, let's take a look at our next problem. What is the area between two circles with radius 1 that pass through each other's centers? Okay, so first thing I'm thinking is we should certainly be drawing a diagram of what's going on here. So we have a circle like this, and we have a circle like this, and we're supposed to find the area of that region. Okay, so they both have a radius of 1, so the distance between them here is 1. Okay. It might be easiest to just break up this area into smaller areas and compute the area of each of these things. Okay, so what I have here is I have two triangles, two equilateral triangles of the same size with a side length of 1, and then I have 4 of these sort of circular arc things. They're also all going to be the same size. So what I'm going to do here, just for clarification of the areas in computing, I'm going to say A1 is area of one equilateral triangle. A2 is the area of circular arc. Well, I guess I don't. What is the proper word here? A circular wedge. With angle. What is 60 degrees? Pi over 3. Okay, so in fact, what I'm calling A2 is the area of this figure here. So it's the triangle plus this sort of circular, small circular slice. A3 I'll call I don't know what the proper word for this thing is, but we'll call it the area of a thin circular slice. And this means that A2 is equal to A1 plus A3. But it's going to be easier to compute the areas of A1 and A2 directly. So you can see from the figure right away, if you look at this slice of pi, and if you subtract the equilateral triangle, then you end up with the area of this thin piece here. And the area that I'm looking for the area between the two circles, we'll call that A, and we know that A is equal to 2A1 plus 4A3, which if I make some substitutions and rearrange here, this gives us 2A1 plus 4, A2 minus A1, which is 4A2 minus 2A1. And these should be easy to compute. Okay, so let's just go ahead and compute A1 and A2. Well, A1 is the area of an equilateral triangle, which is what? It's the so if I have any triangle, theta, the area let's call this x and y. The area is x, y, cos theta. Nope, it's xy sine theta. And in our case, x and y are both equal to 1. So this is going to be sine of pi over 3. And A2 is the area of the circular wedge, which is going to be the area of the circle, which is pi, multiplied by 1 over 6, right? Because the wedge is a sixth of a circle. Okay, so then the total area we're looking for here is 4 times pi over 6 minus 2 times sine pi over 3. I don't remember, you know, my trig functions for common angles. Maybe we can just figure this out. Yeah, okay, so pretty sure I did this correctly. If I drop down this line here, then I know it intersects the base at the midpoint. So this distance here is a half. Some Pythagorean formula allows us to solve for h. It is root 3 over 2. And then sine theta, opposite over hypotenuse. So sine of theta is just going to be equal to h in this case, root 3 over 2. So we can sub that in here. And so this area is equal to 2 pi over 3 minus root 3, which, if I plug into my calculator, I should get an approximation here. 0.36 approximately. Yep, so fairly straightforward problem altogether. Always helps to draw a diagram for something like this. That way you can identify exactly what area you're trying to compute and break it up into smaller, simple areas that are easy to compute. And then, you know, knowing the relationship between the area of a circular wedge and the angle that determines the size of that wedge, that allowed us to compute A2, and some basic trig and triangle geometry allowed us to compute A1. Thanks for watching.